Hey everybody, Ryan Chichak here. Very excited today to be talking about fine-tuning, showing an end-to-end demo in Databricks, really getting into a model we downloaded from Hugging Face, any model you want. Right now we're gonna pick between a 1B and a 3B model, and then we're going to fine-tune the model. And we're gonna do this inside of a notebook. And the idea is really simplicity, hitting home how simple an end-to-end demo is in Databricks, fine-tuning an existing model, then looking at the statistics in MLflow to figure out what hypertune parameters work for the model you output, and then finally model serving with inferencing. We're going to do the entire end-to-end demo today and talk about each step. A lot of platforms claim to be able to do an end-to-end demo, and I want to show just how simple it is to actually do it within Databricks unedited. Let's begin. The very first thing I want to do is I'm going to show the GitHub page that all this magic happens. And you can emulate this right now. You can clone this in your Databricks repo and follow along with me within this notebook. And the whole idea is the framework we're going to fine tune with today is we're going to use Unsloth with sweep. And we're going to choose the Llama 3B model from Llama version 3.2. And really a shout out to Jian, who actually did the heavy lifting with this notebook. And I basically took the hard work that Jian did and I added some to it, meaning that I was able to create some checkpointing inside of MLflow, and then this way we can run a baseline of what works the best for your data. And we're going to be fine-tuning with conversational data that it's really easy to create a table in Unity Catalog. And this is all part of this notebook. The first thing I'm going to do is I'm going to download and clone this. And I already have this running in my workspace. So let me just go through this with all of you. I want to keep this short and sweet. I'm not going to actually, I have a model already deployed, but I'm going to actually run this with you. So as I said, we're going to use Unsloth sweeping. The very first cell in this notebook is really creating that Unity Catalog table for the conversational data that I talked about. And you can see you can change your catalog name, your schema, and table really easily within this notebook. And just to show you for absolute clarity, there is no table right now, okay? And I can refresh this, and you can see there is no table. So the first thing I'm going to do is I'm going to do GPU serverless using the A10s. Soon, there'll be H100s, which are much bigger than the A10s. And we're going to let that start up. And while that starts up, you can see this is going to be choosing the GPU accelerator, and everything today is going to be serverless. I'm not actually creating any infrastructure in AWS. Everything is Databricks serverless. I'm going to run this cell now that serverless is up and running. And you can see it's going to create this table in this catalog and schema, and then it's going to insert these 3 rows. And then as soon as that runs in a couple seconds, we're going to be able to refresh and see that table is actually there and created. All right, so that is complete. You can see the table is complete a couple seconds ago. And you can see it's ready for the next step. And the next step, very simple and common. This is the dependencies for installing pip. We're going to do that. We're going to let that run for a little bit. And it is a good practice to not just do this in a cell, but you can actually add the dependencies here and apply versus just doing the pip install. And we're going to let that run for about a minute or so. And then while that runs, I'll go to the next cell. And this is really the cell where all the magic happens. This is where the distributed GPU framework in Python is executed upon, and you get to pick the GPU type. And then this is where we can hyper tune the parameters. And you can see Gian has done a great job of going through these parameters and talking about which each of them is and how to tune it and how to optimize it. This is something that you can take the time if you're interested in to make changes yourself. But what I'm going to do is I'm just going to run this. And you can see today we're pulling the Unsloth Llama 3.2 3 billion instruct. And you can also do the 1 billion instruct. It's going to be a bit of a smaller model. Again, we're going to fit in those A10 chips. You can see this ran for 12 seconds. It's all done. And we're creating a checkpoint. Ultimately, you can see the hyperparameters. And then you can tune those as needed. But the most important piece here is once you set that up to train, again, fine-tuning that model, we're going to be able to save this checkpoint into MLflow. And we already did that. And then that is the most difficult piece here, is running that. And then finally, this is going to pull the table data that we already ran. That's part of travel conversation variety. And this is how the fine tuning of the model is going to actually happen with that conversational data from the table. It keeps this really streamlined, and it's really, all you have to do is do another insert to insert some data. Or just to add some more data to fine tune. And really, it's how your model is going to learn from those conversations. And it's really nice to do fine tuning, as you all know, because you're not going to have to retrain a model from scratch. This is taking a model that already is out there and the GPUs have already been burned, and that's an expensive process. Fine tuning is just adding your data set to learn. And then when someone asks a question to the model for the LLM, it's going to answer based off the data you provided. So it's really a streamlined process. And you can see here are the 3 runs. So using sweep, we are running 3 different experiments simultaneously. If I go to my job run, you can see here are the 3 jobs that are running. Again, all at the same time. And then everything is being tracked in the experiments under the experiment here. And you can see this is where the 3 experiments are running right now. And I've already done this before, because this will take about 5 minutes to run for 3 billion, which is still pretty impressive. And you can see that I've already picked which model that I found the most efficient. And the way I did it with my metrics, I can choose which metric I want to compare and I care about. And in this case, I wanted to learn the training loss and the learn rate. These were the ones that were the most important to me. So I'm going to pick the one with the lowest train loss. And in this case, this was my model. And then once you have your model complete, if you go in here to see how simple this is, you just click on register model. And then once you click on register model, you create a new model and name it whatever you want to name it. And you can say test ABC model and click on register. And what that's going to do is inside of your models, test ABC model, it's versioning right now, version 1. And if you make any changes, you run another job or another couple jobs, you can register this exact model and will just increase the version by 1. And you can create tags and descriptions. And then here's where the magic happens, where if you want to use real-time inferencing and you want to do model serving, you can either click use model for inferencing, or you can go to the serving tab here and click on create serving endpoint. And you can see right now I have 2 serving endpoints. I have the travel model endpoint and then another endpoint that I created, or endpoint. And what I want to do is if I click on my travel endpoint and I say use, this is how I can quickly interact with my model without doing a bunch of authentication with tokens on curl and what other APIs. I can just do it from the UI to keep this really streamlined and cohesive. The keyword today is cohesion throughout Databricks. I'm able to do this end to end with very few clicks and just a lot of simplicity. So this is what I provided to this model, because if you look at the 3.2, which was trained many years ago, Southwest was still offering free baggage. But what our conversation history had was that Southwest no longer offers free baggage after May 28th of 2025. If you ask this question to this model, it's going to know that, because again, it's using that fine tuning that we provided in our table in the very first cell. And you can see it answers based off of the conversation history that we provided. The really neat thing that I love about this is if I go to, let's say I go to the Llama 4 Maverick, and if I interact with this model right now, and I basically just ask the same question, and this is the latest from Llama. See, this is the latest from Llama, and you ask, does Southwest still offer free baggage? And the answer, it's saying, yes, it's still true, but it's because this model was created 2024. It's not like our model, which we fine-tuned. And this really, if you're a company like travel or any kind of with any vertical, you're going to take what's data is relevant to you, and you're going to make your model learn from it. And then you can basically just deploy that model and ask questions, and you don't have to go through the complexity and, you know, the latency and all the things with something like a RAG, where you have an endpoint that you're going to retrieve data based on the question, pull that back in a vector, and make a decision based off of that. This is fine tuning, and it's making things a little bit sweeter and more straightforward. I think this shows how easy it is to use Databricks, again, as a cohesive platform. You can see these 3 jobs have successfully completed. And if I go back, you can see it took about 4 minutes to run. And I can see which model is the most efficient. And we would do exactly what we just did, registering the model. So if I want to serve up that ABC model that we just created, I can say ABC endpoint. And this is exactly what I'm going to do. I'm going to choose my model. And in this case, I just have a model registry, but I could choose Unity catalog if I wanted to under my catalog and schema. And then I get to pick my CPU type or GPU type, depending on what kind of model that I just fine-tuned. If I want to go a little bit smaller, like a 1B, I could maybe go GPU medium. But in this case, if I have a 3B, maybe I'll go a little larger. And then I can pick my scale out of how network is going to be handled. And then I can do advanced configurations. But the idea here is that you can really optimize this and make this really simple for your enterprise. And then if you want to pick rate limits based on users or endpoints themselves, you can do that. You can tag this so you can understand what the costs are associated with it. And again, everything is serverless. And that's exactly all you have to do. It's that simple. I keep using that word, but it's really, in Databricks, we let you do that. So you go from 0 to 100, heck, in a couple of minutes. And deploying this model will probably take between 15 to 20 minutes, but we're not going to sit here and watch paint dry. I just wanted to hit the point across of how simple it is to fine tune a model, and then actually look at the hyperparameters, compare those, and then actually deploy those for inferencing for end users. And that's all I have today. I'm really excited. I hope you're able to follow along and actually do this yourself. If you're interested, there are some, if you're going to use serverless, which that's what we did today, if you have strict outbound destination set up, you're going to actually use these allowed policies or allowed domains. And this will let you access outbound to do the things like install pip packages, pull models from Hugging Face, and then finally serve up models for your inferencing. I hope you have a great day, everybody. Bye for now.